So, in the last lesson, we talked about the idea of and or, and not. There's a wonderful visual aid to help you figure out the difference between and or, and not. And they're called Venn diagrams, named after a mathematician who popularized them. His last name was Venn. He really didn't do much else for math, but they're sort of used all over the place. And he didn't even invent them. He just published them in a book that became popular, for what it's worth. So, review. Oh, Venn diagrams are visual aid. The following is taken from example 2, last lesson. We said two groups. We have all the set A, all the natural numbers less than 20 divisible by 3. 3, 6, 9, 12, 15, 18. And set B, all the natural numbers less than 20 divisible by 5. 5, 10, 15. It says, using appropriate notation, list the set of whole numbers less than 20 that are, okay, divisible by 3. I just rounded them off. I said it was 3, 6, 9, and I'm going to move down a line, 12, 15, 18. Did I miss any? 3, 6, 9, 12, 15, 18. I think I got them all. What about the ones that are divisible by 5? 5, 10, 15. They're set B. What about divisible by 3 and 5? Okay, so the set would look like this. How would I write that in actual notation? I can put a symbol in the middle. Ah, I just heard his brain click. He just said, oh, and in English is like intersection in set notation, because intersection was the overlap, the things that appeared in both and. So now we have a fairly short way to write and. And that's also, by the way, Jake, how I remember this symbol. What lowercase letter does that look like? Or an N, and almost sound like whatever, you've got to have some tricks to keep all this straight. So I know U is union, and I know the thing that looks like an N is and intersection. Oh, got somebody here? Got a latecomer. Okay. What about divisible by 3 or 5? What number? Okay, it would be 3, 6, 9, 12, 15, 18, 5, 10, 15. Oh, I don't need to say 15 twice, right? Ah, how could I write that in set notation? What are we talking about with or? Union. Yeah, really it's A union B, and I'm not going to write them out because I don't have room, but I think you guys could. You can also get that tie visually from a Venn diagram. So here's a Venn diagram. It's a rectangle. U, the universal set, is on the outside here, and in this Venn diagram we have two smaller subsets, A and B, and you'll notice they overlap a little bit. We put every number from 1 to 20 in here, but we put it in the appropriate region. 15, that's the overlap between set A and B. But can you see, here's set A, Jake, it contains all of those. Set B contains those, there it is. The universal set contains both A, B, and their complements, whatever's not in A and B. It's a nice visual way with, to be honest, in my mind, less thinking, that I can tell you what the intersection is, that I can tell you what the union is. It's almost just like counting, almost. The elements in each set are marked with a dot to distinguish them from the number of elements in each set. So We put dots on them so that you don't somehow think it's telling you there's 7 items or 6 items, for what it's worth. Notice the following. Numbers by 3 and 5, 15, there it is, the overlap. Numbers by 3 or 5 are in one circle or the other circle or both. The complement which is how I could write that. That's 1, 2, 11, 17, 4, 7, 14, 13, 8, 19, 16, although I'd probably write them in order if I needed to. So there is a picture of what we did last class. Hopefully this next bit is pretty obvious. In each of the following Venn diagrams, shade the region representing the given set. A says the intersection of 2 sets, the set A and B. Underneath it, I'm going to write A intersection B, just to help remind you of the notation. What would I shade in here? Yep. You guys get to color. B, the union of the 2 sets. We would write that as A union B. What would I shade in here? This, and that, right? C, the complement of the set A. What would I shade in? So you ready? Would I shade here? Would I shade here? Would I shade here? Yes. Does that belong to A? It does not, then yes. Would I shade here? Yeah. The complement would be this outer section and this section, but not the overlap, and well, but not all of circle A. That's a picture, Brianna, of not A. And when we do probability, one of the tricks we're going to use to solve these questions is going to be a Venn diagram. So we'll get good at these. Turn the page. So example 2 says, consider the following 2 sets from the review on the previous page. Once again, natural numbers less than 20 divisible by 3, natural numbers less than 20 divisible by 5, where the universal set is natural numbers less than 20. In each of the following, okay, lightly shade the region representing the given set. Okay. Shade set A. Right? What's n of A? And remember, lowercase n is our abbreviation for the number of, how many? 5? Is it? 1, 2, 3, 4, 5 or 6? It's tough for me to tell. You know what? I should, instead of using, you know what? I'll use the highlighter shade because then I can still read it. N of A equals 6. Shade set B. Okay. I think like that. What is n of B? Oh, let's put n of B equals 3? Okay. Shade set A prime. Jake, what does prime mean? Oh no, I think it was Matt. What does the little apostrophe mean? Complement, not A, right? Okay, so what numbers am I going to be covering up? Okay, the outside. Darian. I'm going to shade in B as well, but not all of B. Look up. Why am I going to carefully color that little half moon in, but why didn't I color the 15 in? No.
Because that's part of A.
It's part of A. Yes, it's also part of B, but this says shade in anything that's not part of A. A prime, a complement. What's n of A prime? Stop. I could count everything that I've colored. Can anybody tell me a faster way that I could figure out the number of elements in A prime? Yeah.
Take the total number and minus the answer you got for
Yeah.
shade set A.
20 take away 6. Sometimes it's easier to subtract than to do the counting. You know what? N of A prime is 14. You guys can count and confirm if you really, really, really want to, but I'm pretty sure it's right.
It's 19 because it's less than 20.
Oh, so 13. Ben, Candy. Okay, it says shade set B prime. Try that one on your own. I'll do it up here. I think that. Now, you'll notice, by the way, underneath each box there's 2 bullets because, in fact, first of all, why don't I cleverly do this and I can make it bigger since we're zooming in on one of these at a time. Underneath each box there's 2 bullets. They want us to write it in set notation, so in set notation I would write this as B prime, which they did at the top, but we're going to get more complicated as we go. And what is n of B prime? 16? Did you count or did you subtract? Subtracted. 16. You could count and confirm. Intersection A and B. Okay, which ones are in A and B at the same time? All you're going to color in is that puppy. Darian, how many elements are in that set? There it was faster to count than subtract. Oh, and in English, you would read that as A and B. A union B. Now remember, in English, this is the same as A what B. Union is the same as what? Or. Okay. What am I going to color? What am I going to shade in? I think anything that's inside a circle, right? Excuse me. He already has, thanks. What's n of A or B? 1, 2, 3, 4, 5, 6, 7. What's n of ob? Of A union B? Is it 8? Yes? Giovanni, even though that 15 appears in Giancarlo, good song, sorry.
Oh, no, that was my grandfather's name.
Well, it's also, I taught a Giovanni in another block, and that brain is also in my brain, name is in my brain. It's me. Giancarlo, even though the 15 appears in both circles, did you count it twice?
No.
That's going to be a problem when we get to more complicated questions. You're going to find yourself accidentally double counting stuff. When we get to the combinatorics unit, especially when we look at card questions, especially when we start looking at card hands, you'll often find, Mr. Dueck, my answer is exactly twice as big as the back of the book. Yeah, you double counted accidentally without realizing it. And it's far tougher to avoid than you realize. Next page. Oh, more on the next page. A prime intersection B. I don't know. Here's what it's saying in English. Numbers not in A and at the same time in B. I'm not sure, because the way you're saying it could be correct and could be wrong depending on what you're thinking when you're saying, oh, it's just B. Because I don't think it's, well. Why didn't I color the 15? Okay, it doesn't satisfy the first condition. The first condition says it can't be an A, which left everything in the outer rectangle and in the right-hand circle of part B, and it has to be in B. Okay, it's those ones. In English, we would say not in A, but still in B. The word still is optional, but I think that'll help you. Not in A, but still in B. Oh, that's those three. What is n of A prime intersection B? Two. Easier to count than subtract. All right. Let's shade A union B prime. Let's shade A combined with anything that's what? Not in B. So let's shade A combined with anything that's not in B. Mr. Dueck, why'd you cover over the 15? The 15 is in B. It says combined with, or means one or the other or both. So look at the number 15. Is it not in B? No. But is it in A? Yes. So it satisfies union. Because union or means one or the other or both. A or not in B. That's what that statement means in English. What is n of A union B prime? Don't count. Minus 2 from what? Not from 20, but from 19. So in your head, please, Brendan, without a calculator. There you go. Okay, I'm getting this. By the way, can you see this is a nice visual method to help me figure out what we're talking about here. Much easier than the abstract stuff. All right. Hey, Rachel, what do those little prime thing mean again?
The opposite.
Yep, not. So, not A. What does the and mean? Intersection, or in English, and at the same time, not B. Ah, Brendan, did you hear him? Say it loudly. It's the outside ones, isn't it? It's going to be these puppies. That is not A and not B at the same time. What's its N? By the way, I hope you're also noticing, oops, I did union. I meant to do intersection. Whoops. I hope you're also noticing the English is a lot longer than the symbols, which is why we're going to go with the mathematical symbols. It's a nice shortcut. How many are in this set? 11? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. 11. A prime union B prime. Union means one or the other or both. So not A or not B or both. Yeah.
Wouldn't it be the same answer as A and not B? Because you can't have both.
Well, you know what? Since it's union, let's do the first one, color everything that satisfies that criteria. And then let's do the second one, color everything that satisfies that criteria, and then Hannah will just zoom out and see what we've colored. So which of these are not A? Well, that would be this. And that would be this. Right? Or, which of these are not B? Well, that would be this, which I've already colored. And that would be this. Oh, this is another way of saying what? Everything but the 15. You know what this is the complement of? This is the complement of where we started right near the beginning, the intersection of A and B, which was 15. This is that complement. The union of everything that's not A and B, A or B. See how we got that okay? Is he alive? Is he alive?
Oh.
Yeah, come on, it takes a village. Got to help him out. Hey, what's the n value of A prime union B prime? By the way, Alyssa, you saw how I didn't know how to do that, so I broke it down into steps. I said for union, for or, it means one or the other or both. Well, why not color in the first one, identify it, then color in the second one, and whatever is completely left blank is the not. Right? How many? 18? Couple more, we're done. And then we'll move on to a different idea. Shade, the intersection of shade, the opposite of the overlap between A and B. Right? Ready, Darian? It says, first of all, find the overlap, the intersection between A and B. Everything that's not that. What is the overlap between A and B? What's not that? The same diagram we just did. Here's another way to say what we just did. You're going to get, again, so apparently the complement of the intersection of A and B is the same as A prime union B prime. In English, in fact, Mark, if you really want to be generic, not the overlap. Anything that's not overlapping. And this one, oh, geez, Dueck, also has a size of 18. Yoink. Mr. Dueck, this is the most coloring I've ever done in math class. Woohoo! Can we bring pencil crayons, Mr. Dueck? Yes, you can. Okay. This last one. A union A or B or both, but not that. So A or B or both. The opposite of that. Not A or B. What? Darian, nice and loud. Everything on the outside. This is another way to write the same one that we had earlier. I think it's going to be everything out here, because the union of A or B would be everything in the circle. And this is saying not that, everything outside of circles. And it has an n value of 1, 2, 3, 4, 5, 6, 7, 8, 11 again. Turn the page when you're done that. Okay. Try example 3, all of them, on your own, just by listing what's in each group instead of coloring. I'm going to freeze the screen, Amrit. I'll do it up here. Let's see if we end up in the same spot. If you get stuck, check with your neighbor or whatever, okay? So there's our groups. I have no idea what these numbers are from, but I can see the Venn diagram. To get you started, I think set P is 1, 2, 8, 9, 10, right? Right? Set Q is going to be these 4. All right. Wow, that's terribly messy. Oh, G, H, I, and J. Okay. Not P and not Q. At the same time. I think that not P or not Q. Not P would be not Q would be not P or Q. Okay, that's also going to be, hey, good. Not P and Q. Okay. Which ones are identical? Well, any other ones identical? Maybe. 2, 2. Okay. 2, 2, 7, 7, 8, 9, 11. I think H. About 2 more minutes. The last few are tricky. Anybody watching this on YouTube right now is pretty bored because they've just been sitting here. That's okay. About 10 more seconds. You awake now? A, I just listed them. 1, 2, 8, 9, 10. Yes? B, set Q, I went 1, 7, 10, 29. All right. C, I was fine on. And, that's the overlap. 1 and 10. D, I was fine on. That's one or the other or both. And I put them in numerical order, although you don't have to. So I said, okay, there's a 1, a 2, a 7, an 8, a 9, a 10, and a 29. Then it started to get tougher. So not P, I said anything that's outside of circle P. There's 4 of them, 7, 11, 16, and 29. Not Q, that's anything outside of circle Q. Hey, that's going to be 2, 8, 9, 11, 16. Then it got really tough. So then it said not P and at the same time not Q. I said, okay, what numbers are both at the same time not in P and not in Q? 11 and 16. I was kind of proud of that one. I'd think about it. Not P or not Q. I said, okay, the numbers that aren't part of P are these 5. The numbers that aren't part of Q are these 4, these 5. Or means those guys in the same group. And you'll notice I found it tough enough that I didn't actually put them in numerical order. I was just going across the diagram from left to right, worried that I would miss some. Although if you went in numerical order, I applaud you, then you were able to keep track better than me. So I said there's going to be, well, if I go in order, a 2, a 7, an 8, a 9, an 11, a 16, and a 29. Not P or Q. So P or Q are both circles. What's not in both circles? Those two, 11 and 16. What's not P and Q? P and Q is the overlap. What's not that? Anything that's not in the overlap. All the rest. Which two pairs of sets I noticed are identical? G and I and H and J. Go ahead. Did I miss one? I might have. I didn't check my... Yeah. If they're not in order, that meant I found it tough enough that I was just going to move my eyes across, keeping track with my finger, rather than jumping around back and forth trying to put them in order, because I was worried I might miss one. I have trouble with these. I like them. Venn diagrams can also be used to represent the number of elements in each set, and not the actual elements, as the next class example illustrates. So the numbers in the sets are not marked with dots because you're not saying that set S has a 12, a 3, and set Y has a 3 and a 7. Instead, that's saying how many there are in set S. How many there... Well, here's what it says. This diagram displays the number of students who are members of the student council and the yearbook committee. How many students, grand total, are on student council? What, Taylor? 15. See it? How many students are on both? 3. How many students are on yearbook but not on student council? Which one, 10 or 7? Right? On yearbook, but at the same time, not on student council. How many kids are on yearbook, grand total? 10. How many are doing yearbook and not student council? 7. How many are on the student council or the yearbook committee? 12 kids are on student council. 7 kids are on yearbook. 3 are on both. 22. Drawing Venn diagrams. This is important, and I'm going to show you a good trick. It says in a homeroom of 20 students, 15 take math, 12 take socials, and 10 take math and socials. Show this information in a Venn diagram. Are there some that take both? That's going to be the key to drawing this. So the first thing that we're going to do is we're going to draw a rectangle. I suck at drawing these, so I'm going to cheat. Ha-ha. And inside here, I'm going to say, okay, I got math, I got socials. The most common mistake, Carm, that kids make, don't write this down, is they go, 15, 10, and 12. Now, don't write that down. Why is that wrong? How many students are in that Venn diagram, grand total? From what I've drawn, how many are there? 37. How many does it say are in the class? Okay. So, when you're trying to fill in a numerical Venn diagram, there's going to be 2 approaches. If you know the overlap, you start on the inside and work your way out. Or, if you don't know the overlap, you start on the very outside and work your way in. Hannah, what's the overlap? How many take both? I'm going to put a 10 right there. How many take math? Grand total. How many take math? Grand total. 15. How many only take math? 5. See the 15 kids taking math? How many take socials grand total? 12. How many only take socials but not math? 2. Ah, how many kids take neither math nor socials? How do you know? Good, Darian. You spotted it. You started. It doesn't add to 20. That must mean that's my complement. 3. That's what's left outside. How many cool kids? 15. How many losers? 5. 15 kids take math. Losers don't take. No. Okay. Okay. I think this is our last one? Yeah, last one, and I can turn you loose. I'm going slow because this is very foundational. So, here's our survey. 400 households. What that means, Darian, is when I'm done, everything better add up to 400. 285 had personal video recorders, PVRs. And 320 had multifunction printers, MFPs. Let's use P for PVR, and let's use M for printer. That's okay. M for multi-function. 63 had neither. Okay. Did they give me the overlap? Put an X there. How many have a PVR? Grand total.
285.
285. Algebraically, how many have a PVR but not a multifunction? How could I calculate that? In other words, how the heck did we get that 5 from that 15? So what am I going to do here?
Subtract from 463.
Come back here. What's the overlap? How many? I put a number there, sort of. X. So, do you see it? Did we see it? How did we get this 5 from 15 with this 10? What did we do? Subtracted. All right. I'm pausing, hoping somebody sees it.
Subtract the printers.
Isn't that how many are in there? I mean, I don't know what X is, but isn't that what I would do? How many had a printer? Grand total? 320. How many have a printer but not a PVR? Mathematically.
326.
How many had neither?
63.
Where am I going to put that 63? There's our setup. Okay? So no matter what, Laura, we're going to start from the middle. If we know it, we'll put the value there. If not, put an X there. Now here's the key. How many people, grand total, did we survey? In other words, what do all of these have to add to? 400. What do all of these have to add to? 400. One more time. What do all of these have to add to?
400.
So if I hear you correctly, what you're saying is 285 take away X plus 320 take away X plus 63. What does every single region have to add to? We can get an equation. We can get an equation. See it, Rach? This is being clever. I like this question. I like this question. I like this question.
Is this question going to be on the test?
You didn't hear me say that. You're the kind of student that tends to notice when a teacher emphasizes certain things. I also like the previous question. I mean, that's great too. But to me, this is a more interesting one because I'm being a bit clever. And I'm pulling out some graded equation solving. Oscar, you may notice I have a minus x and a plus x. Those cancel. Felt sad, F fractions, no. Expand brackets, no. LT, like terms, you know what? I can go 285 plus 320 plus 63. 285 plus 320 plus 63, those are all like terms. I can simplify this equation to 668 take away x equals 400. Just intuitively, Grayson, I think x is going to be 268 because I think 668 take away 268 gives you 400. But let's solve for x. How would I get the x by itself? That's part of the 400, right? 400 people were surveyed. So printers plus both, PVRs plus both, plus multifunction, plus whoever didn't, that all has to add to 400. That's our universal set n number. Is that okay? How would I get the the x by itself? Minus 668 from both sides. You'll get negative x equals negative 268. Divide by negative 1, divide by negative 1, the negatives will just cancel. X equals what? Now, let's go to the Venn diagram and actually put in the numbers. How many are in the overlap? 2, 6, 8. How many have a PVR but not a printer? Whatever 285 minus 268 is, which is what? $17. How many have a printer but not a PVR? $52. And if you check the 3 red numbers plus the blue 63, that better add to 400. Double check real quick, but that's my final check. Does it?
Yep.
Okay. So there's our trick for solving Venn diagrams. If the Venn diagram is all about how many, if they give you the overlap, subtract your way out. If they don't give you your overlap, put an X there and still subtract your way out. But then you have to come up with an equation. What's your homework? One is good. Three is good. I skipped 2. 4 is good. 5 is good. Physics! 6 is great. Sorry. So far I've skipped 2. 7 is good. I'll let you think about 8. I haven't done that yet, but it's drawing pictures, and how often do we actually get to draw pictures in math?
Feels like a maybe.
No, 8's homework. 9 is good. I'm going to skip 10. I think I'll pause there. I'll skip 10 and skip 11 and skip 12. Okay? So, from 1 to 9, skip 2. Is that what it was? So from 1 to 9, skip number 2.